All right, so the next idea is that once you understand, you can estimate the area under the curve using rectangles. What we want to do is we want to think of a way to get this to be more accurate. And the idea is that if I have more rectangles, the rectangles themselves will actually get skinnier and skinnier. And if they get skinnier and skinnier, and you have more of them, then it would be more accurate to the line. Okay? So here they're actually just writing it as using sigma notation. So let me sort of go through all the symbols. This triangle here means change in x. Okay? So you'll see that it says here, on the interval from A to B, divide by however many rectangles you want. And that tells you the width or the change in x. So, for example, on this problem, delta x, the change in x, was just 1. It's whatever the width is going to be. And you get it from doing the interval divided by how many rectangles you'll have. Now, to get the height, they're talking about the right endpoint. It corresponds with the value of the function at that point. So what that means is you're just going to plug in the x values, and then you'll end up with how high it is. Okay? So you'll see down here that the area is equal to plugging in this value, because if you plug it in, you'll get the height, times the change in x, how big or what's the width. So each time this is just height times width, height times width, height times width, height times width, and so on forever. Notice all of them are going to have the same width. They're all going to have the same delta or change in x. So you can actually factor that out. And then you just have all of your heights added together. And so what they've done is they've gone ahead and written this with summation notation or sigma notation, and said that I goes from 1 up until n, meaning however many rectangles you have. Okay? And then they've just sort of shown you that you can put the change in x at the end. It doesn't matter. It can be at the front or at the end.